dividing polynomials. And even though I'm going to start with long division, the main goal here during this video is to make sure you're comfortable with using something called synthetic division. Again, you would have gone over this in your Algebra 2 class. And so again, I'm going to start with long division, just so you're familiar with the process in case you're unable to use synthetic division. But the whole goal here is to make sure you remember how to do the synthetic division process. So let's start with long division, like a fifth grade problem. So I'm trying to figure out 178 divided by 3. That's what this first one is, right? This is 100. Oops, sorry about that. 178 divided by 3. So remember, you put the dividend, which is the 178, inside the division symbol. The divisor is 3, and we're going to get an answer, which will be called the quotient. So 3 cannot go into 1, so 3 goes into 17 5 times. So 5 times 3 is 15. Subtract. 17 minus 15 is 2. Bring down the 8. 3 goes into 28 9 times. 9 times 3 is 27. So we get a remainder of 1. So I can still remember being in 5th grade and writing R1, but then learning in middle school that really it's not R1, it's 59, and the fraction that's remaining left over should be 1/3. So 3 goes into 178 59 and a third times. So the idea is if you multiply 59 times 3, you're not going to get 178. So you need to multiply 3 times a third to get the extra 1 that's left over. Okay, so let's kind of apply that to what it would look like if we were dividing polynomials. So more complicated process here. One thing I want to point out on this question is if you look at your dividend, what's inside the division symbol, it has 2x cubed minus 3x squared plus 4x plus 5. That's not missing any terms, right? It's starting at x cubed, then it goes to x squared, then x to the first power, and then the constant. So if it is missing some term, like if it just skips one or skips multiple, make sure you put what I call a placeholder. So like if it was missing x squared, I would be writing 0x squared. It's not, so I don't need to write that. But I just want to make sure you are looking out, keeping an eye out for placeholders. All right, so I'm going to ask myself, how many times does x, so that's the first thing I see on the divisor, how many times does x go into 2x cubed? So essentially, what do I need to multiply times x to give me 2x cubed? So I know I need a 2, and I'm going to multiply it by x squared. The reason I wrote it there, it doesn't really matter. I wrote it there is that because that's on top of my x squared term in my dividend. So that's just kind of like, I like to organize it for my brain that way. So now multiply what I just wrote, 2x squared times x, which is 2x cubed. Now guys, this should not be a shock to you, but that should be the same. Or the whole point is that when you do that, you should get the same thing because we're going to subtract to make that 0. Now in this case, my divisor has a second piece, right? It has that plus 2 on the outside. So I need to multiply 2x squared times 2, which is plus 4x squared. So I'm going to subtract, right, just like I did before. That's going to be 0. Negative 3x squared minus 4x squared is negative 7x squared. And I'm going to bring down the 4x and the 5. Okay, repeat the process. How many times does x go into negative 7x squared? So essentially, what do I need to multiply times x to get negative 7x squared? And it's minus 7x. Would multiply to give me negative 7x squared, but then multiply the negative 7x times the 2 to get minus 14x. We're going to subtract. All right, that's going to be 0. 4x minus a negative 14x is really adding 14x to get 18x. Then bring down the 5. Almost there. What do I need to multiply times x to get 18x? That's just going to be an 18. And then 18 times 2 is 36. So I subtract, and I get my remainder of 5 minus 36, which is negative 31. I'm not going to write r of 31. I'm going to write minus, as I just showed you. You take your remainder, and you put it over the divisor, which is x plus 2. So this is my answer. If you look at the bottom of this example here, you can see we started out with a dividend that was inside the division symbol. We have our divisor. And if I were to multiply that divisor times what I just got, right, my quotient plus my remainder, then I would end up getting my dividend. Okay, I'm going to show you that a little bit simpler way once we get a little further in the lesson. Okay, so that's long division. I'm going to do 2 more with long division, but just know that the whole goal here is to try to avoid having to do long division, right? Because as it says in the name, it is a longer process than the synthetic division we're going to do. So x plus 1 is my divisor. Inside, I'm going to write 5x squared plus 3x minus 2. All right, so same process. Something times x to give me 5x squared, that would be 5x. When I multiply, I get 5x squared. Multiply by the 1 to get 5x, subtract. That's 0. 3x minus 5x is negative 2x, and bring down this minus 2. Something times x to give me negative 2x is minus 2. That's going to be negative 2x, and then negative 2 times 1 is negative 2. Oh, look at this. I subtract, and I get 0. So what that means is if you get a remainder of 0, it means that this x plus 1, right, that divisor we just used, is actually going to be a factor of this polynomial. And if you just take a moment just to look at what we have 5x squared plus 3x minus 2. If you're to use the slide divide bottoms up, so slide this over to get x squared plus 3x minus 10. Give me factors of negative 10 that add to 3. That's going to be x plus 5 and x minus 2. Put them over that number we slid. So if you finish it, you get x plus 1 times 5x minus 2. And if you look, those are my two factors here, right? I have one factor, which is the divisor, and one factor, which is the quotient. So if I were to multiply these two out, I would end up with the dividend. All right, so that's kind of the whole kind of process with all the vocab that you learn when you were in 5th grade, but now we're kind of applying it in a tougher context with polynomials. All right, let's try this next one. So I'm going to put 4x plus 5 over here, and we have 16x cubed. Again, be on the lookout for anything that you're missing. I haven't had to do any placeholders yet. Right? That is going to come later in the lesson. What's something times 4x? That gives me 16x cubed, so it's going to be 4x squared. So I multiply, it gives me 16x cubed. 4x squared times 5 is plus 20x squared. Subtract. And you get negative 12x squared minus 20x squared, which is negative 32x squared. Bring down the 20x and the minus 3. So now I'm going to do something times 4x to give me negative 32x squared, which is minus x. That gives me negative 32x squared. Multiply the negative 8x times 5, which is minus 40x. Subtract. So that's going to be 0. 20x minus a negative 40x is really adding to get 60x. Bring down the minus 3. And then that's going to be plus 15 times 4. Is 4x is going to be 60x. 15 times 5 is 75. Subtract. You get negative 3 minus 75, which is negative 78. Remember, that's the remainder. We write that as minus the remainder over the divisor of 4x plus 5. So that's my quotient, my answer for this first one. You notice I did not get 0. So my dividend divided by 4x plus 5 is not going to give me say that those two are factors because I didn't get 0. Okay, hopefully you guys are seeing, now that you've watched this part of the video, how long this is taking and how much work it requires. A lot more work, a lot more writing. So we actually have a faster way to do this, as long as, I'm going to highlight here, as long as this is in the form of x minus a. All right, now I know it says x minus a, right, and you see addition. All that means is that you just have to think opposite when you start by putting your number in the corner. So if you look at this number in the corner, that came from the fact that the divisor is x plus 2. So think of the opposite of plus 2, which is a negative 2. These numbers here, right, so these numbers here are the coefficients from your dividend. So you got your 2, your negative 3, your positive 4, and your positive 5. Notice it doesn't have any things missing, so I don't need any placeholders. If you do miss any, you need to put a 0 as a placeholder. So to review how you did this when you're in Algebra 2, you're going to first bring down that leading coefficient of 2. Then you're going to multiply the things that are below the line times the number in the corner. So 2 times negative 2 is negative 4. Now, the key thing about synthetic division that's different than log division is that we're going to add. So negative 3 plus negative 4 is negative 7. Repeat the process. Negative 7 times the negative 2 in the corner gives me positive 14. Add straight down. Get 18. 18 times the number in the corner gives you negative 36. Add straight down, and you get your remainder of negative 31. So how you would write this, right? And this is a mistake here, okay? But how you would write this is we started with x cubed, right? See how we started with x cubed? So 1 less than x cubed is x squared, and this first 2 is going to start off those coefficients, and it decreases. So minus 7x to the first power, plus 18 is your constant, and then minus 31 over your divisor of x plus 2. So this is the process that we're going to practice and that I need you to be confident with to get into synthetic division. So that way it's a skill, a tool that you're going to use when you have to solve for your roots or your zeros of polynomial functions. All right, so everything I just kind of said is summarized in this table about how to set up the problem. I'm going to go with the fact that you've done it before and kind of just show you some more examples. So if this is my divisor, I'm thinking, all right, the number in front of x is 1, so we're good there. It's x to the first power, so also good. So what's the opposite of minus 3? That would be a positive 3. So I'm going to write down my coefficients here, 5, negative 3, and negative 36. Again, I did not see any things that were missing, right? There's no placeholders I need. So let's bring down the 5. 5 times 3 is 15. Add straight down. You get 12. 12 times 3 is 36. Add, and you get 0. If you get 0, right, there's a couple of things that this means. The first thing it means is that this 3 is actually a root or a solution or 0 of this polynomial. So if you were to plug in 3 into 5x squared minus 3x minus 36, you get 0. If you were to graph 5x squared minus 3x minus 36, it would cross or hit the x-axis at 3. It also means, for the purposes for us, is that x minus 3 times, all right, and I'm going to do my 1 less than x squared is 5x to the first power plus 12, right? These are the factors of 5x squared minus 3x minus 36, all right? That's what happens when you get 0. Let's do this one. Okay, finally, it says, is the first expression a factor of the second? So think opposite here, all right? So you're going to put your opposite of minus 2, which is positive 2. Now here we finally are missing one, right? See how we skip x squared? We go from x cubed to x to the first power. So there's no x squared. So I need 3, negative 6, 0, negative 5, and positive 10. Bring down the 3. 3 times 2 is 6. You get 0. 0 times 2 is 0. 0 plus 0 is 0. 0 times 2 is still 0. Add, and you get negative 5. Negative 5 times 2 is negative 10, and you get 0. So is this first expression, x minus 2, a factor? And the answer is yes, because you got 0 in your remainder. And if you wanted to write down the other factor, go 1 less than x to the fourth power is x cubed. Take that 3 is your coefficient of the first one. I don't have x squared. I don't have x to the first power, but I do have minus 5, the constant. Okay, so again, if you were to multiply these two together, you would end up getting this dividend. All right, let's do 2 more. It says essentially the same thing we just did to see if the dividend is a factor of our polynomial, of our divisor is a factor of our dividend. And then if it is, write down the factor terms. So again, it's in the form x minus a. Even though it's a fraction, you can still do this. So we think, what's the opposite of minus 1/2? A positive 1/2. So I'm going to put that in the corner and write down 2, negative 1. I have to write a 0 for x squared, 2, and then minus 1. So don't forget about those placeholders. Bring down the 2 times the number in the corner. So half of 2 is 1. Add straight down, you get 0. 0 times anything is 0. 0 plus 0 is 0. 0 times 1/2 is 0. 2 plus 0 is 2. Half of 2 is 1. So when I add this, I get 0. Because that's a remainder of 0, yes, x minus 1/2 is a factor. I can write down that factorization as, remember, 1 less than x to the 4th power is x cubed. So take that first coefficient to start it off, 2x cubed plus 0x squared plus 0x plus 2. All right, let's do one more and then we'll be done. So the opposite of x plus 1/3 is negative 1/3. So put that in the corner. 3, positive 1, 0, that placeholder, negative 3, and then positive 1. Start the process, bring down the 3. 3 times negative 1/3 is negative 1. Add and you get 0. 0 times anything is 0. 0 plus 0 is 0. 0 times anything is 0. Add and you get negative 3. Negative 3 times negative 1/3 is positive 1. And when you add this, you get 2. This is not 0. So x plus 1/3, write this again, x plus 1/3 is not a factor because we did not get 0. All right, so you get a chance to practice a ton with synthetic division, and don't forget to try the links.